What is named pipes in SQL Server protocols? Can you answer this question? If not, please go ahead and see my previous video on the explanation of SQL Server protocols and how they are used and what is the purpose of it. In continuation to the previous session related to the protocol layer, which I explained on the protocols, what are the types of protocols and use of protocols and how each protocol is used. So we were reviewing this particular thing, and as part of the protocols, yes, we completed this protocol and think that we passed the protocol test and we entered into the connectivity of the SQL Server with SSMS. So, what is the next step of our architecture? What happens in the background after we connect to the SSMS? So, here you can see we are connecting to the SQL Server with SSMS means SQL Server Management Studio, and from here there is three ways of how the SQL architecture runs in the background. So, number one is called CMD parser, means command parser. Command parser is a functionality or a feature which checks the syntax of the query we are executing. And here is the syntax, the feature which we have is command parser is executed on the database engine to check this particular query is valid or not. So who takes care of all these functionalities? The command parser. Command parser is responsible to validate the syntax errors before proceeding to the next step. I hope it is clear to you. If you still have any doubts, you can add in the comment section. I can respond back to you with the another video or the comments. So next step. So now our command parser is failed. Oh, okay. We can fix it by selecting the command parser. So some commands successfully completed. So we completed command parsing. The query which we are using, we completed the command parsing. What is the next step here is the optimizer. Plays very important role in the SQL architecture. What is an optimizer? In short, I will tell you an example. Think that you need to go to some place where that place have three routes, and if you search that particular route in Google Maps, it will show three routes, but it will select the best route which is having less traffic, which will reach in the shorter time. This is where the optimizer also works. The optimizer is responsible to send the plan for this query. If I am executing this, it will have it can as execution plan. It will create a plan. It is called as an execution plan. The plan is called as execution plan. Execution plan is nothing but whenever we execute a query, it will try to check if there is any plan or if there is a route already existing, so that it can identify the best possible route so that it can reach to the destination as soon as possible. Here destination reaching means sending out the output as quick as possible. This is where the optimizer helps for SQL Server to execute the queries faster. But where are these plan execution stored? Whenever I execute this, the plan will be stored. A execution plan will be stored in some place in SQL architecture that I will show here. So the SQL command parser is responsible to check the syntax errors of the query which we are executing. And if you go to the optimizer, optimizer is responsible to identify the best possible path to give the output. So that is called a plan execution or execution plan. That all execution plans will be saved in the plan cache. So all these are interrelated, and the optimizer plan cache or optimizer execution plans are saved in the plan cache. I'll tell you later about this plan cache, but you understand now optimizer work is to identify the best possible route to give the output faster as possible, so that it follows the execution plan. That execution plan will be saved in the plan cache. So that is the functionality of this optimizer. If you see here, this is the functionality of the optimizer. So I hope you understand this, what is happening in the background once we execute. Which executes. So the query executor, what it does is it will it will send out to the next level. This level which we are speaking, the command parser, optimizer, query executor are part of the relational layer. Which we are discussing is relational layer. Here query executor is responsible to execute the query with the dependencies it is having. So execute the query. So to execute the query, it need to reach the layer which is called storage layer, because the data and everything related to the data is saved in this particular storage layer. Here you can see this is the storage layer. This is the storage layer. This is the storage layer. And whatever the query to execute, suppose I want to execute a select query. So the data of this query is saved in the storage layer. The data of the output, suppose I execute this, or else I'll execute some other query also, not an issue. So whenever I execute, this particular data is saved on the storage layer or on the disk related information. So all this data will be stored in the storage layer. So the query executor, what it does is it sends out the information to access method. Here, what is an access method? I hope you are clear now with the command parser, optimizer, and executor. Executor task is to execute the query by sending out to the next flowchart, next available flow. So here we are seeing here executor is sending out the data to the access methods. Access methods functionality or the feature is to identify the query and send out to the next step. So access methods identify the query. Access methods identify on two types. One is select and another one is update or delete or anything. These are called DML and DDL activities. DML and DDL activities, we'll look into that later. But now, to make it simple, we will take an example of select. Coming to the access methods, then the access methods send across to this side, to the buffer manager side. If it is a select query, it will send to the manager side. And if it is an update, delete, or anything related to updating the data related, it will send out to the transaction manager side. Okay, we'll look into that. Now we have a select query. Query executor have a select query, and the select query is sent out to the access methods. Now access methods will identify it is a select query, and it is sending the select query to the buffer manager. As I already told, the optimizer have the execution plan in the plan cache. Plan cache is nothing but it stores the execution plans temporarily. So execution plans are not permanent. If you execute this select star from this one, it will create one execution plan. But if you execute something like this particular thing, it will create another execution plan. If we have a select query only, it will have one execution plan. But if we have it is having another query where the query is changed, then it will have the plan, the execution plan will also be changed and saved in the plan cache, where the plan cache is responsible to hold all the execution plans where the queries are getting optimized, or where the queries are getting optimized in this particular command or in this particular feature. So all these execution plans will be saved in the plan cache. So our example here is we have a select statement, and whenever we execute a select statement, it will create a plan and it will save here. And the query executor send the to the access methods saying that this query is related to select. Then access methods will come to this side. As I told, select is this side, and it will check whether what are the plans available for this query. So I have these two plans. I have the two plans saved in the plan cache. Now I will try to execute this one. Then what buffer manager does is it will identify a plan, and to the it will identify the plan, and it will respond to the user based on the plan. As I told, it is having a shortcut to get the data. So the plan means it will also be having some data pointed. Suppose I have this particular select query executed. I have a plan with 16 rows. Means that the buffer will save that particular 16 rows temporarily. Means that if the plan is matching to the execution, this data will be sent out to the user. But where the data is coming, the data will be coming from data file where based on the plan. So based on the execution plan, the data will be fetched from the data file, and it will be saved, it will be responding to the user in this way to the user. So I hope you understood this particular query executor example with select. So if the query is related to the update, we were discussing related to select, where the query will come here, access methods will identify it as an select, it will go to the plan cache, it will check the execution plan, and it will get the data and it will respond to the user. But if it is an update query, what it does is access methods initially send out an update to the transaction manager and records that particular update in the transaction log. That update or delete or any data changes activity will be updated in the transaction log initially. Later, once the transaction is completed only, it will be saved in the data file. So the update is sent to the transaction manager. Transaction manager wrote the data in the transaction log, and it sent out a response to the data. Once the activity is completed, once the update is complete, it sent out to the data, and the data file will be saved. This is how the flow saves differs between the select and the update. But here, in the both ways, the buffer manager and the buffer pool will be used, so that it will hold the temporary data and uses that temporary data whenever required. Example, it will have plan cache, dirty pages, all these. What is a dirty page? Suppose you are trying to execute 1 lakh rows, you are trying to update 1 lakh rows. If you try to execute 1 lakh rows, all the 1 lakh rows will not be updated immediately. The rows need to be updated slowly, chunk by chunk, point by point. During that time, the buffer manager will be useful, and that particular data will be until it is committed, that particular data will be saved in a page which is called a dirty page. So means a temporary page. Once the execution completes, then it will go to the data file and saves the data. Until that, the page will be a dirty page. Once the transaction completes only, it will save to the data file. So here, as the data dirty page, it is also part of a buffer manager. You need to understand or remember, buffer manager is like a temporary storage where it stores all the temporary information, and it clears out whenever the temporary information is not required, or the buffer manager is full. And if the plan cache, suppose you have an optimizer, you have an execution plan created a 1 month back, and you want to try it now, it may not be available now because it is very old. The plan cache execution plans will be cleared based on the pressure on the buffer manager. It will always holds the latest data which is being frequently used, not the query which was used 1 or 2 months back. This will have the data which is frequently used. So this is how the flow and the process works for the transactions. I hope I explained clearly all the steps. One is the protocol layer, which is having three types of protocols. If you remember, you put that in the comment section. And after that, we have a relational layer. In relational layer, the query will be verified for syntax, optimized, and sent to the execution. And the execution will identify whether it is a select or update. If it is select, it will check the data, it will go to the plan cache and it will check the data, and it will fetch the data from the data file. If it is a new plan, if it is a new query and the plan is execution plan is not available, it will create a new execution plan by fetching the data from the data file. If it is already available, it responds to that user directly. And if it is an update or updating or deleting any data, it will go to the transaction and it will write that particular in the transaction log, and it responds. After that, once the transaction is updated on the transaction log, once the activity is completed, that particular data will be saved on the data file. I hope this is very clear. If you still have any doubt, any question, you are always welcome to add your questions in the comment section. I'll be replying back. So here we completed the architecture level information. On the next session, we will be looking into the base concepts of pages, database files, and all. So for now, we are good. I don't want to club all the other activities or other sessions into this. I want you to focus on this architecture so that once you are clearly aware of what is happening in the background, it will be easy for you to understand how the process is being run.